Based on the following factor tree diagram, A, if n is a perfect square, what is it equal to? And B, if n is a perfect cube, what is it equal to? First of all, for a perfect square, all factors, including prime factors, have to come in pairs. This is because a perfect square represents a number multiplied by itself. As an example, for the number 36, it can be written as 6 times 6. Note that there are two 6's. It can then further be broken down to 2 times 3 times 2 times 3. Note there are two 2's and two 3's. We can then write 36 equals 2 times 2 times 3 times 3. For a perfect cube, all factors, including the prime factors, come in groups of 3. This is because perfect cubes represent numbers multiplied by themselves 3 times. As an example, consider 216. We can write that as 6 times 6 times 6. Note that there are 3 6's. We can then further break up each 6 into 2 times 3. Note that there are 3 2's and 3 3's. 216 then can be written as 2 times 2 times 2 times 3 times 3 times 3. For A, we want n to be a perfect square. We can break up the prime factors into pairs. Note that there are 3 3's, 1 5, and then we have E and F. We can take 2 of the 3's and put them as a pair. We can then take the other 3 and it has to be multiplied by E. So E would have to be also a 3. We can then take the 5 and it has to go with the F. We can then say, as I mentioned, E has to be 3 and F has to be 5. We then multiply all of these prime numbers, 3 times 3 times 3 times 3 times 5 times 5, giving us a result of 2025 for n. For B, this time we're going to group all of the prime factors into 3's. Right away note that we have 3 3's. We have 1 5 left over. It has to be matched up with the E and the F. This means that both E and F must be 5. We can then multiply all of the prime factors, 3 times 3 times 3 times 5 times 5 times 5. This gives a result of n equals 3,375.